First of all, thank you all for showing up. Most of you I am not familiar with, and definitely I look forward to talking to all of you after a short presentation that I have. Feel free to make it interactive, especially in the later part. This is based on actually the Amenge thesis of Stanislav Nicolau, who is sitting, where is he? Yeah, there he is. And unfortunately, I'm going to lose him to Twitter, and I don't know why. Okay, so what is the topic? The topic is we want to figure out what things become trending, and in particular, as we know, on Twitter, things go viral, and question is that can we predict before things go viral? So now, when I started looking at this question quite a few years back, there are a few misconceptions I had. So just so that we all understand what is the precise question we are talking about, let's start with one simple setting. So just so that we all understand, we all know Twitter. Twitter is, at some level, nothing but a global communication network. It's a new way for us to communicate to a large audience that we could not do before, right? I mean, there were telephones, even before telephones, there were mails that we sent, which are so asynchronous, but one-to-one. And then there were telephones, which were instantaneous communication. But then there was lack of asynchronicity, and then emails came around. It was great. And then Facebook came around, where we had friends from which we can communicate both ways. And the Twitter, which is allowing us to reach all those people which we can't reach or we don't even know before. So this is a great communication networks. And what sorts of things happen, as most of us or all of us know, and maybe you know better than I do, people tweet things like this, and it'll be a short message, no more than 140 characters, as we know. And it will have a few interesting things. And in particular, the way I'm highlighting here, the interesting thing here is election day. It's a phrase, it's a bunch of words that end up coming up in various tweets. Like in my tweet, it will be election day, do this. Your tweet would be election day, do that, and so on. But it's election day that's becoming important, right? So it's that topic that we are interested in. So we're not interested in one particular tweet that somebody's sending. We're interested in the topic that is being tweeted, and it's possibly tweeted in different contexts. Okay, and what we would like to figure out is what are the topics that are trending. That is, in this context, somebody would say election day with schools, somebody would say election day in New York, somebody would say election day Boston. But many people will say something about election day, and we want to find out, is the election day trending? And if so, can we quickly figure that out? All right? So that's going to be the goal of this, or this is the point or problem that we are going after. All right, so here is a few examples that I'm going to walk you through, just to explain what precisely are we doing in terms of solving the problem. And then I'll tell you a summary of results. And at that point, I'm going to stop talking. That'll be the end of the monologue. And hopefully, there'll be a dialogue that will begin. Okay? All right, so as many of us know, Barclay was in news in some recent past. Does anybody know why it was in the news in recent past? They made a lot of money. LIBOR, thank you. They lost a lot of money. Let's see, they were fined a few, close to $500 million or something like that. It's like biggest scam detected in the history of banks. The idea was that Barclay was manipulating interest rate in the LIBOR case, and that's what becoming very popular. And of course, once this kind of information hits the news, it becomes fast spreading news. Okay? And indeed, that was what was happening. This is the timeline. This happened on June 27th. This is the British time. Of course, understandably, it's Barclay. And what I'm showing here is, in some sense, tweeting rate normalized appropriately. And what this shows is that suddenly around this time, Barclay as a topic started coming up in a huge number of different tweets. Somebody was saying, wait, Barclay is losing money for this. Somebody was saying, Barclay fined, and so on and so forth. So Barclay as a topic became trending. And this is when Twitter announced, well, Barclay is trending. So in a sense, what Twitter sees is like a NASDAQ. Twitter sees that, well, this stock price has become really high. Let me now announce it, that it has become high value. What we want to try to figure out is, before it became trending on Twitter, can we predict it earlier? In particular, let's go back here. Is there some information here maybe that will let me say that, well, I think by this time I should announce that the topic has become trending? Okay? And maybe if I could do that, that would be nice. And I'm sure many of you would know better application of that topic than I would. But with that in mind, let's try to sort of understand how well will our algorithm do in terms of predicting this before time. And here is a plot. Ignore all the numbers, all the not so good looking notations, Greek symbols, and so on. What I want you to focus on is the following. This is the time when it became trending on Twitter. There is 12:49 British time. We ran our algorithm on that data set, and we try to see when will we predict that topic becomes trending. And as per our algorithm, topic becomes trending roughly an hour before. Okay, and depending on your point of view, R could be extremely valuable information or information a little ahead. I mean, there's a quote that I'm remembering right now. Is a great professor of statistics. His name is Tom Cover. He recently passed away. And I was just going through some of the quotes he had. And this one that sort of comes perfectly handy here is the following, that he said, you know, hindsight is extremely useful thing. The unfortunate thing about it is that it's not available when it's really needed. So maybe this might be solving some of that problem. All right, let's look at some other example. This is the only example where we can do it. We picked another example. That's a very good-looking woman, Olivia Culpo. She was Miss Rhode Island, or she's Miss Rhode Island, and she happens to be Miss America too. And she won the Miss America pageant this June. And again, as one would expect, this is the type of topic that Miss Rhode Island would become trending. And indeed, that happened. Miss Rhode Island became trending, and let's say at some point, Twitter reported that it is trending. Again, we ran our algorithm, and roughly 2 hours before, we could say that, well, Miss Rhode Island is going to become trending. Okay? All right, so these are the two examples. Hopefully, I've whet your appetite by now. Now, if you're sitting there and you are asking, you might be wondering, well, is it really that big deal? Because why not I just declare for all topics that they're trending? And I'll be way ahead of time in terms of predicting what things become trending. So what does that mean really? So how do we verify whether sort of, are we doing the right thing? Well, one way to verify that is, on trending topics, I should declare that they are becoming trending. And on non-trending topic, I should not declare that they are becoming trending, right? And that's what in statistics / machine / inference, whichever name you like to attach with those communities, is something called, people would try to estimate what's called false positive and true positive rates. Okay, there's an error, right? I could always say nothing is trending, and I will always have error for trending topics, but no error for non-trending topics. I could always say everything is trending all the time, and I will have no error on trending topics, but all error on non-trending topics. So really, it's the balance that I want to get correct on trending and correct on non-trending, right? And when we look at this thing, this is how it looks as an ROC curve, okay? Don't want you to read too much into this. The thing I want to look into this, so if you have seen these things before, you know what it is. You will say, that is a pretty good kick-ass curve. And if you have not seen it, then what you should do is that read this. What this says is that we, on the large sets of data sets that we ran, 95% accurately we can predict things that are getting trending, and we'll make 4% error on non-trending topics. Okay? And that's, in a nutshell, the essence of our work and results. And I think this is roughly the time when I should stop, because I think I'm 8 to 9 minutes up, and it would be better if I let you ask me questions other than I continuing. So thank you for your attention.
All right, sir, here's a microphone for you.
So do you mind if I now move around? Excellent.
Thanks, very interesting. Can you go back to the Barclays slide, possibly, or just think back to the Barclays slide?
Given that I don't know you, it would be great if you ask a question and you just tell me a little bit about yourself.
Sure. Jeff Moore, I work at a local venture capital firm.
Okay.
On the Barclays timeline, maybe can you point out when it was publicly disclosed? Like if someone had done a Google search, when they would have found?
I don't remember that. However, there was a news, so I don't remember when it was published. I think the question you are asking is that, am I predicting things before they actually happened, right? Or something like that.
Yeah, I'm just curious.
Yeah, I don't think this was early enough in this particular event. Okay, great question.
Yep.
Yes, please.
Hi, my name is Joe. I work at a data science group at a marketing company.
Okay.
So I'm curious have you tried, tapping into maybe like the streaming API on Twitter and seeing if your model will trigger something, like have a trigger for something that's going to become streaming, and then like wait an hour or two to see if it actually becomes trending topic?
So your question is that we should run this algorithm on Twitter data?
Well, have you tried collecting
So actually,
real time?
this is from Twitter data.
Well,
We had access to full Firehose.
So is this, like, did you collect the body of the Barclays data, for instance, historically, right? You ran your model, and then you said, okay, it trended at time X, and we predicted time Y. Have you tried collecting real-time tweets and seeing if you could identify a topic that will become trending and then waiting?
Sure, that would require us to build a full-blown infrastructure.
Yeah.
And hence we have not done it. But I would bet my life on this, that this would do as well.
Sir, I've got a microphone for you.
But it's a valid question.
Yes, Todd Curtis, airsafe.com. We deal with a lot of aviation safety news and information. And my question is this something that can be used in a more local fashion? That is, something that might be intensely interesting, let's say in a city where a plane crash just occurred, but not necessarily something of national or international interest?
Oh, definitely. So I think his question is that, can we localize this to topics or let's say geography? And definitely you could do that. And there is enough information about this. For example, if you had full access to Twitter, you should be able to do that.
Sorry, the microphone's coming for you.
Sorry, my name's Wasim Kawaf. I'm MIT Sloan MBA. I was just wondering, is there any way you could cut down that error rate from 5%? Or is that fixed? Is there no more margin that you can kind of bring it down to 2% or 1%?
I would love to if I could.
Right.
As you might be familiar, I didn't just say use the word kick-ass for the heck of it. It really is pretty good because, when you play with this kind of estimator, especially classifiers, getting these kind of ROC curves is pretty tough. We were pretty surprised. I was not expecting this good ROC curve. So you're right. Can we shave it off? Maybe if I, instead of we using, let's say in deciding this thing, we used extremely small data set. Roughly 250 trending topics, labeled trending topics, and roughly 250 non-trending topics. Now, replace those 250 by 250,000. Possibly we might gain some more information.
Oh. You said there's for that 5%, can you give us some examples of some of the false positives you guys saw trending and didn't trend?
Sure, we had examples. I don't have them on slide. If you're interested, feel free to email me and we can follow it.
Professor Shah, it sounds like you might have a prospective student, actually, for your lab. I was wondering, where do you see yourself going with this algorithm? Where do you want to take it next?
Well, I think, all right, so there are different, let's put it this way. At some level, this is an exciting intellectual method which is helping figuring out how to classify time series data in a different way. I haven't explained you the algorithm at all, and I'll be happy to talk to you offline if you are interested. But it's a very simple data-driven algorithm, and it's a totally new view in my mind, looking at this large data statistics or large data analytics. It's related to this non-parametric way of doing time series classification. So in that sense, it's not just restricted to this social Twitter data, but you could apply to many other time series settings to, for example, detect events that are going to happen suddenly. For example, let's say when is the I mean, I wish I could do that, but when is stock price is going to go up based on history? Can I figure that out using this method? And so on. I mean, you start thinking about different applications. Maybe some of you can tell me right now, what application will be your favorite application to put this?
Eric.
Yes.
Looking for adverse events in a clinical trial of a new drug, for example?
Excellent. Anomaly detection.
Or just any rare event for me.
Excellent. In all of that cases. So I will have reasonable corpus of not rare or daily event, regular event happening. And when I will find that things are different enough from that, based on time series, this would work there.
I would imagine maybe the Department of Defense or Homeland Security might be interested as well in
Definitely, I
using
hope
it
they are interested in that.
Mm-hmm. Yeah.
Hi, Peter Dzikas from MIT News. Just had a quick question to sort of follow up on this. It seems, following up on your answer here and a couple of other questions, obviously there are different types of circumstances in which things trend, right? With the Miss America pageant or whatever, it's trending just because everybody has watched a TV show at the same time.
Yes.
Right? As opposed to chatter about financial markets or whatever. Are you sort of, to what extent can you kind of separate out and do separate studies based on the types of events that cause something to trend, and then see what sort of different types of curves you're getting and what sort of rate you're getting?
Great. So actually, this is a fantastic segue into something that's going to last for a few minutes, so pardon me for that. So Peter's question, rephrasing or paraphrasing it, is like this. Well, things trend in different ways. Events like Barclay trend in certain way, maybe events like, hey, Sandy's coming, stock up your food, trend in different way possibly. And there might be many different ways things are happening. So you can look at the data and you can look at the time series, and then you can say, well, what should I do? Well, it looks like some of the trending topics looks like there's a silence for a while, a little bit of activity for a while, and then boom, sudden spike. Some of the things look like there's a slowly growing activity, and so on and so forth. So there are all sorts of such different patterns. So let me see if I can behaviorally figure out what sorts of different patterns are likely. And then in those classes of models, let me model them analytically and learn parameters associated with it from data to fit those and patterns, and then identify those patterns. We tried that. We tried it for quite a while. We failed miserably. And then in a moment of frustration, Stan and I decided we are going to forget about all this giant world of parametric models. It's like too complicated world. This parametric model, that we're not going to do that job. We're going to let the data do that job. And the hypothesis is the following, that tweets are tweeted by people. People behaviorally are complex and difficult to predict and understand. However, in their actions, they're simple. Okay? So really, people's actions are very simple. And so if I have lots of tweets and trending available, maybe the few different types of ways in which things become trending are already hidden there. So why don't I design an algorithm that somehow reads that off from data directly without my building the model? And here, what we are really banking on, and the fact that in the modern world, computation is not that expensive. Computation is cheap, but centralized computation is very expensive, or it's not possible. What you can do is that you can take your big data and divide it into pieces and put into different machines, and then do some computation here, some computation here, some computation here, and generate one numbers each from each machine, and put them together, add them up, and look at it, whether it's greater than 0 or less than 0 on one another computer. If it's greater than 0, declare that it's trending. It's less than 0, it declares it's not trending. And that's essentially what we do. Does that help your, to some extent, I hope?
Here you go, sir.
Hi, my name is Rohan. I'm a student at the System Design and Management program at MIT. I had a question about the sentiment analysis for trending topics. Are you doing sentiment analysis for the trends? I mean, can you say whether the trend is a positive trend or a negative trend, and people are talking positively or negatively about the
right
topic?
now, all we're doing is we're just detecting, we're just classifying whether something is trending, going to trend or not trend.
Okay, thank you.
Hi, my name is Mark. I work at a hedge fund. One of the questions I have for you is, are you doing anything classifying tweets by cloud score category, for example, news tweets versus, a human tweet versus, someone who's, has many followers, et cetera, to base sort of, what the importance of that event or that tweet is?
No.
Okay, it's a good idea.
It's a great idea. It's a great set of side information. Amazing thing is this works without any of that. Yes.
Hi, I'm Kurt Hasselback. I work at the MIT Museum. I'm just curious if there's any way to apply this algorithm to anticipating traffic.
Yes. So now the question is that do you believe that tweets
or predicting traffic?
Yeah. So if you believe that there are people tweet enough about, let's say, 90 becoming jammed, just reasonably enough in advance, if that's the case, I would say yes. I don't have personal experience with that. I had one experience with driving in Palo Alto, and it was, Palo Alto, as you might know, it's a reasonable town. It has jams, but nothing like bad ones. And then there was a friend who was with me, and he believes in Twitter, really. And there was a jam, he immediately looked it up and found reason why it was happening. So who knows?
Hi, my name is Bryce. I'm actually a computer science PhD student at MIT.
Great.
Have you also looked at when a hot topic or trending topic will be out of topic or out of fashion?
So now you're sort of asking more refined question. Question is that given let's say a time series, can we start predicting what would happen to the next phase of time series?
Something that will go out of fashion.
Yeah. So this method could be immediately extended to do that. It has a lot more than just classification. It can actually start predicting next segment how it will go.
Yeah.
So in a sense, it's like this, right? There's sort of how much is future of past is future of future, and we believe that is the case, and hence this is working. Sure, Larry, you.
All right, I'm Larry. I wrote the story that's up on the news site. But the question about traffic, you interpreted that question as referring to Twitter data, but what if you actually had data on traffic patterns, on the volume of cars going past some, time series data on that kind of thing?
Sure, then definitely we could use that to apply on this. And again, traffic patterns, I think there are only a few ways in which, like if you read literature on transportation, so one of my background is in networks, and networks looking from a detailed dynamics level. And in transportation literature, there's a huge work that's done trying to understand what sorts of traffic pattern lead to actually serious traffic jams. And in particular in UK, especially around these ring roads, and people have done beautiful detailed analysis, and you must have experienced this. There's a wave pattern that you go through. It's like we humans are just impatient. As soon as we get empty space, push it along, and then there's a jam that happens, and then there's a wave pattern happening. So there are a few such different ways in which things happen, and hence, if you have some reasonable sensing data, maybe actually, as we all know, or I don't know, Google does have a reasonable amount of data on you. So if we get dead races, sure. By the way, I have to comment, one way to become trending is to have Larry write something about you.
Nate Nickerson, Director of Communications for MIT. I wonder if you've, since this came out, talked to anyone at Twitter about this, and if so, what they had to say.
I'll be happy to talk to you offline. No, well, jokes apart. For example, there's a great friend and a colleague at Stanford. His name is Ashish Goel. He's an academic. He has spent a lot of his time working at Twitter. And intellectually, this is really an interesting question. And it's definitely, a lot of people are trying to solve it across the globe, not just at one company. So.
Any other questions to be asked out in the open of Professor Shah? No? All right. I think he might have a few minutes maybe for people to come up to him, and possibly Stan might be able to stick around as well. So please join me in thanking him once again.